Now on to section 6.5. So the notes I have for section 6.5 is the multiplication property of radicals. We've covered this before. So just to reiterate, if A and B, they represent real numbers such that the nth root of A and nth root of B, if they're both real, then the nth root of A times B is equal to the nth root of A times the nth root of B. And also what we saw last time is that we have the nth root of A times the nth root of B. That equals the nth root of A times B. Now let's start with section 3. Example, and it says to simplify, we want to simplify the square root of 12 times times the square root of 54. Right? So first thing, what I want to talk about. So when you multiply, let's take this 2. So since it's commutative, I can move this 2 over to the front. And so 2 square root of 12 times square root of 54. And now if we look at it, so if I use the multiplication property right away, we would have 2 times the square root of 12 times 54. Now, I don't know about you, but I don't want to simplify. I don't want to multiply 12 times 54, and I'm pretty sure you don't. And after that, we would have to simplify the square root. That's gross. So we're not going to do that. What are we going to do? We are first going to simplify the fractions, or not the fractions, the radicals. So I'm going to look at the square root of 12. So square root of 12, the smallest, the biggest perfect square that goes into 12 is 4. Right? And then 4 times what is equal to 12 is 3. And then for 54, the biggest square root is, the biggest perfect square is 9. And then 9 times 5 is 54. Right? So let's solve. So this is 2 times the square root of 4 times the square root of 3 times the square root of 9 times the square root of 5. So I use the multiplication property for this radical and this radical. Right. And then what is the square root of 4? So what squared equals 4? That is 2. Square root of 3, this is as simplified as it can get because there's no perfect squares that go into 3 nicely. And then for the square root of 9, what squared is equal to 9? That is 3. And then for square root of 5, this is as simplified as it can get because there is also no, again, like with 3, there is no perfect square that goes into 5 nicely. So now let's bring all the let's bring all the numbers that don't have the radical and all the numbers that do have it. So this becomes 2 times 2 times 3 and times 3 times 5. Right? So now what is 2 times 2 times 3? That is 12. And then using the multiplication property, I'm going to write it out. So the square root of 3 times square root of 5, this becomes the square root of 3 times 5. The square root of 3, and then 3 times 5 is 15. Right. For safe measure, I'm going to check all of these. So the first smallest perfect square that goes into that's smaller than 15 is 9, but 9 doesn't go into 15 nicely. Neither does 4. So I know that this is as simplified as it can get. And that is our solution.